Mm. Hey guys, good morning. I hope you guys are having as beautiful a day where you are as we are here. So it's a beautiful day in New Hampshire. Sun is shining, the leaves are turning, and it's pretty awesome. If you placed an order for PFG Stones this week, it is either gone or in my bucket for tomorrow morning. Shipment. How's everybody doing? What are you guys up to? Hey Adam, good morning. How's everybody doing? Oh, Chris is here. Everybody behave. Cambridge is on the air. Welcome. All right. So I hope everybody had a great week. I think I have no complaints. So, so far today, I have warmed up the Okamoto. Well, I'm glad you're here, man. I'm glad you're here. And one of these days, I'm coming down to see you. So I'll check with you first before we do anything crazy. Yeah. So, oh, somebody has a question already. Well, let me finish telling you what's going on here, then I'll take your questions. I'll be happy to. So anyway, we're warmed up. We're making, we're making 6-inch stones today because that's what the spreadsheet says to do. And we are going to give a regrind to one of our customers who sent the stones in. I don't know if he wants his name used. So I won't use it unless he shows up here. Then we'll give him infinite grief. Actually, his stones triggered the whole discussion in the last week about cleaning the stones. So actually, it was very valuable having that whole thing happen. Hey, Warren, neighbor, welcome aboard. So I put 3 things on the schedule. One of the things I want to talk about is what does it take to actually cut metal? And I don't have like a definitive academic, discussion about that. But it was interesting thinking that went on. I want to talk about that a little bit. So let's see. Something just popped in. So this is an interesting question. Is there any difference in stand grinding or climb grinding? I don't know that I've heard the word stand grinding, so maybe you could clarify that. I assume you mean what we would call conventional grinding or conventional versus climb in machining. Yeah, okay. So that's a really good question. If we had, if this was a machining question, like we were using an end mill, let me grab an end mill for a prop here. Hold on one second. Yeah. Oh, I got a good one here. Digging through my carbide scrap. Oh, you'll like this one. I needed to have an end mill in my hands to have this discussion. And I picked this one. That's a good one, right? Anyway, so if we were talking about cutting metal, climb cutting is when you are your rotation of your tool is basically in the same direction as your feed, and conventional is when your feed is opposite the direction, the rotation of your tool. So does that matter in grinding? I actually have an opinion about this, and I'm going to ask Adam to weigh in a minute. So Adam, you're on notice. So yeah, good, excellent question. So let's talk about the machining case. In the machining case, if you just think about how the flute of the mill is going into the metal, then in the conventional sense, you're going in hard, you're going in light and you're coming out hard, right? So you're going from the surface, and then when you go to exit, you have taken a big scoop. Whereas with climb, it's the opposite. You're exiting with a very thin cut. So from a finish point of view, climb cutting is better because you're exiting the work having just done a very teeny amount of work. And in conventional, it's the opposite. So in CNC milling, when we have really super good control of the table, because of ball screws, we can do that because everything's fine. But if you go to a manual machine, you can grab the work and yank it through the backlash of the table and end up in a world of hurt, break a tool, ruin the work. So, whenever, if you learned manual machining first, you were always taught, always do a conventional cut because it's not safe to do a climb cut unless it was super light, blah, blah, blah. But in CNC, we are able to just do climb cuts all the time, or most of the time. Okay, so that's machining. Well, grinding is just more machining. So the difference is, I would argue, first I'll argue the case of it doesn't matter. The table is in motion. It's extremely heavy compared to the forces in a grinding cut, because grinding cuts are very light forces. Therefore, it doesn't really matter. So that's my it doesn't really matter argument. And that's why you see grinders all the time reciprocating, and it'll cut one way, cut the other way, cut one way, cut the other way, and nobody cares. It works fine both ways. However, and we're talking flat grinding right now, because we're not grinding like a slot with a radius, which is a lot of what, sometimes not a lot of, but Adam does that. That's a different animal. Let's just talk flat grinding. So the answer for that is it doesn't matter. However, there is a case where it does matter, and I have experienced it. And I will let that hang for a minute while we process that and see if anybody guesses what that is. But Adam, do you want to weigh in on whether you think it matters in flat grinding, whether you're climb cutting or conventional cutting? That would be we'd be interested to hear from you, because I consider you an expert. It depends. See, that's why you're my favorite guy. Flat grinding, no. Okay, so Adam's basically agreeing to, in this argument that in flat grinding, it doesn't really matter. So why on earth did I say that there are cases where it does matter? We got new guys showing up. Welcome aboard. Happy Sunday. So, as you know, I grind stones. I know that you probably didn't know that at all, but creep feed grinding on a surface grinder, it's important. Okay, So creep feed grinding is a special case, and we could touch on that. And Adam hit it on the head. Also, coolant delivery. So that's what I was about to talk about. When you're using coolant on a grinder, which is almost always, usually you're shooting the coolant in from. Well, let's walk over to the grinder, shall we? All right. So the wheel is off, by the way. Okay. So usually we're shooting coolant in from one side, and the wheel is rotating like that. So the coolant is shooting that way, and all the, of course, all the swarf is also shooting that way. So what ends up happening is, if you're traveling, let's see if I can get if you're traveling into the wheel, you are sort of in the shadow. Well, the coolant is getting blasted under the wheel, but really not, because the wheel's touching the work. So it's like a squeegee. So the work is in the shadow of the coolant as you go this way. But as you go this way, you're grinding something that's being, showered by coolant. So there is a difference in the coolant depending on the direction you go in. Now, when I grind stones, there's a lot of low-speed swarf associated with grinding a stone. Let me just grab a stone. I happen to have one here. I know that's kind of hard to believe. So, here's the stone. And when this stuff gets ground with this wheel, it's actually some pretty low-speed phenomenon. If you grind steel, you notice that there's sparks flying out and hitting your shield over here. When you grind stones, that doesn't happen. So the swarf sticks around. And you can actually see a difference in the direction depending on what you're doing. So that is a consideration. And Adam says when slot grinding, the coolant can hydrostatic lift the wheel if using a climb pass. Excellent. So if the wheel's spinning this way and we're driving our work this way, right? What Adam is saying is that the wheel will take the coolant and literally pump it between the wheel and the work, lifting the wheel, providing pressure up on the wheel, hydraulic pressure. You said hydrostatic. We could probably argue semantics, but it's the same thing. So yeah, the pressure could lift the wheel and change your dimension because everything is made of pasta. And welcome, John. Good morning. Adam says, ideally, coolant velocity matches table speed, but we would need a raincoat. Exactly. And Fad Radcater showed up. Good morning. So that was a really interesting point. So yeah, we arrived at where I wanted to go with this, which is that there's an asymmetry right here, which is the wheel spinning this way, but the coolant is right here. So that is a difference, and it may not matter 99% of the time, but that stinking 1% of the time, it could matter. So when you go to program, let me show you, if we went into, I don't know, how about this, and go to this, we can say, do you want to feed from just one side or both sides? That's what this means. And this allows you to lock it in how you want to do the feed. I don't want to get into the super deep details of programming this thing, but you can choose to not do that, and that's an interesting thing. So excellent, boy, that was a great question, Chris. Did you stay up all night coming up with that one? That was beautiful. So anyway, there you go. We're getting set up here. John says, coolant temperature. So, yeah, I don't know that. So for anything that we do typically, I don't think we think too much about coolant temperature. There's my coolant tank. It's got 30 gallons of coolant in it, and it's sort of in the same environment as the machine. And of course, as you use the coolant, it probably is warming up. That temperature could matter to the work, right? The work is seeing a flood of coolant. The machine is seeing recirculating lubricant and the room temperature. So as this guy grows and shrinks, is the coolant going to affect the machine's dimensions? I don't think so, not much, but it's going to definitely affect the dimensions of the chuck and the work. And we're down in microns at this point. So, yeah, that's a very good question. I don't know. I would imagine, and Adam, you could weigh in on this, that if we're doing super critical grinding, that all the temperatures get controlled. There's much fancier machines than I've ever been exposed to that probably do that. I know that the lubricant frequently gets temperature controlled so that it doesn't cause the iron to grow or shrink. And I don't know if anybody controls the coolant temperature. Could you weigh in on that, Adam? Have you seen coolant temperature control? I don't think I've seen it or paid attention to it. Excellent question. Very good question. So Adam says one of the most accurate grind shops in the world uses fish tank heaters to keep the coolant at 75 degrees. There's your answer. The answer is yes. Control everything, and you'll maintain accuracy. Thankfully, we're not down in those decimal places, but yeah, you would control everything. And they use 100-watt light bulbs under the machine castings tied to a thermostat. Sure, absolutely. So in my case, like if we back up here, my machine casting is sitting on a concrete slab. This slab is typically about 55 degrees kind of all year round. So it's 55 degrees here, and then we go up. There's a motor here on the back, and there's lubricant, and that's all kind of warm. So you got cold down here, warm up here. Adam is exactly correct. He says heated floors solves all that. My old shop had radiant heat in the floors, and it was glorious. We don't have that here. We have Mr. Modine up here. But yeah, there's a temperature gradient up the machine, and that matters. So if we were going to go crazy here and say we're going to hold microns, then yeah, we'd temperature control the coolant. We would temperature control, well, the floor and the machine and keep everything constant. And I was told when we set this machine up, I was told in no uncertain terms, the guy who was over here, who was awesome, I've showed pictures of him during that process. He said, you have this thing right next to a door, and if you were doing critical work, we would advise you not to do that. Even windows were an issue. So they're aware of that. And I, basically said, yeah, no, don't worry about it. If I can hold a tenth, I'm happy. And he said, oh, a tenth? Well, that's easy. So that was that was the end of that discussion. But yeah, just having the door open here affects the machine made of pasta. It's going to grow and shrink. But because we're mere mortals, we're not going to worry about that. So, yeah, excellent point. And if you can build a shop with radiant heating, and I'm looking at you, John, radiant heating is the greatest thing since sliced bread in a machine shop. It's the best thing ever, and I miss my radiant heating. What's going to happen when they ban 100-watt lamps? You can't outlaw resistors. Or only resistors would have outlaws. No, wait, only outlaws would have resistors. Something like that. You could always make heat. I guess they call them cartridge heaters when it's a resistor meant to heat something up. It's called a, heater. Yeah, excellent. Okay, good questions. What a fun morning. So, I'm putting you back on top of your solvent can. So what else is going on? What other questions do we have today? We can solve the problems of the world here. We have enough talent. I know that for sure. Swarf and Chips, welcome aboard. I don't think we've seen you here before. Maybe we did. Poultry heat lamps. Excellent. I don't know if I would try those. I'm a little scared. I'm chicken. Sorry. Yeah, I don't think that's a rabbit hole I'm going to go down, so to speak. You should, if you're here today and you haven't yet read, yeah, sorry, Chris. If you haven't, we're going to talk about Adam's parts in a minute here. Hold on. In fact, Adam, I wonder if you'd be open to being a guest and join our video. We've done that once before. So there's a button. We're going to do that in a minute, but there's a button down there that looks like a little camera. And if you hit that button, we can do split screen, and you can join the party here and tell the story about those parts, because I want to hear the story about those parts. I have questions for you, Adam. Anyway, where was I going with this? I don't know where I was going with this. So Adam, if it's quiet enough in there, you could just hit that button and we'll find out about your part. So Adam posted a picture of some gorgeous hard, I believe they're hard milled and ground, and they were stunning because they were two halves of an assembly jig, and when the two halves went together, the seam disappeared. It was pretty cool. Oh, here we go. Let's see. Stand by for Adam. Let's see if this works. Did it work? Hey, it's working.
Hello.
There he is. How are you? Can you hear me? We may be having a little bandwidth.
Locators on either side of the part.
Hey, I'm having trouble hearing you. I don't know if others are, but it might be a bandwidth issue. So we'll give it a chance here, folks. Hey, if you don't try the technology, you don't know what works. Am I the only one that sees Adam frozen up? Yeah, Adam just dropped. Sorry, buddy. I don't know. Yeah, frozen. So you were frozen. The bandwidth, I think, is a little bit chewy. So Adam was trying to join us to show us the parts he just made, which are gorgeous. All right, here we go. We're going to try one more time. Stand by. Okay, yeah, hit that button one more time. Adam, hit the button one more time. We'll try it again. Hang on, folks. Technology is never easy. Anyone who can see this person's live videos will be able to watch them too. Okay, so let's try that.
Hey, it worked.
Hey, that's much better.
All right, perfect.
Welcome aboard. Yeah, go ahead and do your
So
explanation.
these are the parts, and it's an assembly press for Dan Rudolph. But all it really is 4 keystone locators, male and a female, and they kinematically lock the 2 halves together. But not that tricky to make, actually. The trick is to just grind everything after you've cut the locators.
It looks great. So that was all hard milled?
Relatively hard. It's just 4140.
So that's
it's all done with one tool, both halves, and that's how you can maintain the same relationship. The trick is just use the same finishing tool. More of a technique.
That was 4140 pre-hard?
Yeah.
So probably, what, 45?
Low 40s, somewhere around there.
Looks great. Nice tool.
Thank you.
That's awesome. So I think as a result of you joining here, a bunch of people are popping. So,
well, they probably don't want to see me.
Oh, actually, they probably don't want to see me. So while we're here, why don't you show off your Parker-Majestic?
Hang on. So this is my CNC Parker. It's got Siemens 828 control. And then over here we have the manual. And it's got Heidenhain digital readout. And then behind it, that's the Haas. That's the mill shop on the other side of the wall. But, yeah. And then over in this corner is my grind bench, which is a little messy right now.
Very cool.
That's the grind shop.
And you got a new microscope recently, right?
Yeah, this guy. Got a Heidenhain Quadra-Check. And I have 10, 30, and 50x zoom. It's pretty nice. Really good high resolution scales on it. High quality Nikon glass. So I'm very happy with it.
Awesome.
Back to you.
Yeah, awesome. Thank you very much, Adam, for chiming in. Your video could hang in, or you could drop, whatever you like.
I'll jump off. It's your show.
Okay. That's awesome. So thanks for sharing that. You do beautiful work. Welcome here. We'll even feed you. Awesome. So the funny thing is I don't know how to get rid of you. Oh, you dropped off. Okay. So that was a very nice visit from Adam. And I'm sure Adam would tell me if I got any of the explanations of climb versus conventional on grinders wrong. But the bottom line on that question was the asymmetry of the coolant, and the I think that's the big effect. So welcome aboard, everybody who is joining, probably because they follow Adam. I guess I should introduce myself because a bunch of you probably don't know who I am. I'm Spencer Webb. My company's Kinetic Precision. I make PFG Stones, and right here. And I've got an Okamoto. Seeing as we're doing grinder tours, I might as well just show this to some of the new folks. So this is a Okamoto ACC 818NC, which is a Fanuc control on an Okamoto grinder. One of the differences between this machine and Adam's Parker-Majestic is that this is a hydraulic table. It's a pretty conventional hydraulic drive, whereas Adam's machine has a ball screw on the table. And then the two other axes, the head up and down, which is called Y, and the table in feed, which is called Z, those are both ball screws. Hey, Dika.
So that's my machine. And the funny thing was, when Adam and I were talking about CNC grinders, he ended up going with the Parker-Majestic, which is made in the United States, and I went with the Okamoto, which is actually made in Thailand. And I got caught in the COVID import issues. So he got his machine first, and then I got my machine later. And he's doing some great stuff on that Parker-Majestic. The other difference, of course, is this is a Fanuc control, and some people don't like Fanuc controls because they're clunky. And that's true. That's very true. But they're also like bulletproof, and I would welcome a Siemens control. But I have a Fanuc control over there in my milling department, and so I was pretty comfortable with it. So yeah, this feels like Grinderland today. And also, we just recently added the mist fit, which is our mist collector, and that's been working fantastically because I've been able to eliminate the need for my respirator over here, and it's cleaned up the shop, and that's been pretty cool. So that was for the new folks, because the old folks have seen that already. Excellent. So, what other questions or topics do you guys want to bring up that we can talk about today? Usually, we try to keep it to 45 minutes, and we have we're about 32 minutes in right now. Today, I'm making 6-inch stones. I think I said that before, and I'll be in the shop for a couple hours running this guy. So let's talk a little bit about what enables a tool to cut. And I think I posted when I first posted the notice for this for our meeting today, I said that cutting is equal to effective hardness times pressure. And that's a bunch of hand waving, a bunch of imprecise engineering hand waving. Well, what does that mean? Do you have experience with 5-axis grinders? Thanks for asking. No, but Adam does. I'll throw him under the bus, and probably some other folks do. So we're all pretty familiar with, pick up a carbide tool and go ahead and cut your metal, because the carbide tool is super hard. It's probably up in the 80s, Rockwell 80s, and so the hardness is obvious here. And then grab a piece of something, and then the thing we want to cut has lower hardness, right? So it's pretty obvious when you have something that's very hard and something that's not as hard. But I could rub this on here very lightly, and it's not going to cut. And I could do this all day long. But if I put some pressure on it, I can get it to cut. So that's where the pressure comes in. So if we want to cut something like a precision ground stone, we need something harder than the stone. So you have aluminum oxide, which is very hard. We make grinding wheels out of it. So what do you use to cut that? You use diamonds. So we use diamond wheels. So we're always looking for the difference in hardness. So then the pressure becomes important. What does that mean? Well, if I take a microscope and I look at the cutting land of a flute on a cutting tool, it's very, very small. So if I put 10 pounds of pressure on that tool, the pounds per square inch at that edge is very high, okay? And it exceeds a critical value necessary to cut into the material, to literally cleave or displace material that I want to cut. So that's why the pressure is important. because if I don't use any pressure, I don't get any cut. So you have to have both things. You have to have effective hardness. Why is he saying effective? Give me a minute. You have to have effective hardness, and then you have to have pressure. And a grinding wheel is absolutely no different. The trouble with the grinding wheel, I happen to have one here, is that we don't see the flutes. We don't see the cutting edges unless we put it under a microscope. But it's exactly the same thing. You have these grains, and the grains have a hardness, and then we have pressure, which is we're pushing it into the work, and that makes it cut. It's just doing it at a different scale. If you change that equation up, like for example, if you cut hardened steel with a high-speed steel tool, now the margin between the hardness of the tool and the hardness of the work starts shrinking. And if you try to cut high-speed steel with carbon steel tools, which used to exist, you would find out that you're going to fail. Similarly, you could have too little pressure to cut, and that happens. We see that happen. We see the results of that more frequently when you have a work hardening material like a stainless, and you did not, if you're drilling stainless and you let up on the drill pressure, and you work harden the stainless, suddenly you find out that you're in trouble because the material just changed, and now you need conditions that you don't have anymore, and you end up with a problem, which could be a broken tool. So grinding is really is just another cutting process at a much smaller scale. But if the velocity of the cut starts to matter also, and that could have, that's why I say effective hardness. You could take a water jet. We all know about water jets. Hey Ed, welcome aboard. You could take a water jet with no garnet in it, and it can effectively cut, and it can be used to cut metal. Well, how could that happen? Water is not hard. So if you look at that equation, if you make it move so fast, it behaves as if it's harder, and that's where that happens. The effective hardness is high, and then the pressure when it hits the metal is high, and it cuts. So that's why I'm calling it effective hardness. So it's all, everything, when we first learned about machining, everything's kind of black and white. You need a real hard thing and a real soft thing, and you got to jam it in there with a lot of pressure. But as soon as you start looking at it, it's like shades of gray. And that's why I find grinding so interesting, because we have these different materials and different additives. Like, this is, effectively, this is just aluminum oxide, but they add other ceramics, and they have all sorts of fancy mixes, and the reason is to make the cutting more efficient, and it expands what you're able to do. But for basic, if you're just starting and grinding, I'm sitting in front of my my grinding wheel drawer. A white wheel is your basic aluminum oxide, and it has a size to the grains. That's what you're going to start with, and you could do 99% of what you need to do in metal with that kind of a wheel. So anybody have any questions? You can look down and you'll see the little question button down here. Hit the question button and put some interesting question in there. We'll see if we can cover it. And or in the comments, put down what you're doing in the shop today, or if you're not in the shop today. Adam and I find that every Sunday we're in the shop doing work, so today is no different. Hey, John, are you in the shop today, or are you chilling out? Anyway, if you just joined us, oh, here's a question. Oh, that's pretty cool. The question is, and I'm sorry, I don't know your name. Yeah. Palette Designs is kicking his feet up. That's a good thing to do on a Sunday, man. Yeah, and Manos says we all use Sundays to do some work. It's true. So, question on the table: how do you estimate and compensate the grinder loss, which changes the tool diameter within a CNC program? Excellent question. So I consider myself, even though I've been doing it for a few years, I consider myself a bit of a grinder noob. I'm a student of the art, which is probably going to be true for the next 20 years. So I don't know if there's any compensation that is done in CNC programs for grinder wheel diameter. And it's ironic because this wheel that I just picked up, is supposed to be that big. So this has been used up pretty good. But I do know that on this machine, on my Okamoto, I can dress the wheel automatically. And there's a dress cycle for fine and a dress cycle for rough. So, and a dress cycle for initial. So when you go to do some work, the wheel will go over. Here, I'll show you. The wheel can come over to the side of the table here. And this is the straight diamond here. And then there's two side diamonds. So this will dress the bottom of the wheel. These will dress the sides of the wheel. And at the beginning of a program, you can select it to come over and true the wheel. Now it could be one of a number of one of a number of dress forms here, right? So straight grinding, it'll just dress the bottom, but it could also do the edges and do all sorts of fancy stuff. So it can do that at the beginning of the program. It can do that at intervals of how much material you've cut, and it could also do it just before the fine grinding, just before the finish grinding. And that is a way to control the grinding wheel diameter, because when it dresses, it's going to record how much it just dressed, and it will compensate for it in the program. And I have found that is amazingly accurate. So I hope that answers that question. That's how it's done here. The final thing I want to say on that is you get to, let's see. Nope, that's not what I want. Yeah, that's not what I want. Anyway, you get to select. Oh, yeah, I know where it is. Hang on. Main menu, full auto, pattern data, grind conditions. Yeah, you get to select the interval over which it will redress. So if you're doing some heavy grinding, okay, this says if I grind 20 thousandths of an inch, okay, if I grind 20 thousandths of an inch, it's going to dress the wheel, period, and then it'll go back to work. Also, I can come over here and there's this button that says dress interrupt. So if I think that the wheel needs dressing, I just hit this button, and after it finishes the pass it's on, it will go dress the wheel. So those are ways that it compensates. Excellent question. Thank you. And I see Warren says that he was turning aluminum stuff, and this afternoon you're going to go erect staging to do some house repair. You got to do what you got to do, buddy. Got to keep the tent from leaking. Fad Radcater says he's splicing eyes and synthetic tie rope for his lift. Excellent. And there you go. Here's another question coming in. We'll take these in order. I don't know which order they came in. How do you decide between CBN and aluminum oxide on hard steel? Okay, that's a good one. Let's go to the table. So first, let's figure out what the two materials are. And you're specifically talking about, oh, you're welcome, Restless Studio. So A2 tool steel, which, let's just assume for the moment that that's what this is. It's a fair bet. Might be at about Rockwell 60, like you point out. So which one do you choose? So aluminum oxide will grind A2 at 60 Rockwell all day long, and CBN will also do it. CBN is a bit of a specialty material, and maybe Adam could weigh in on this. CBN stands for cubic boron nitride, and it is not as hard as diamonds, but it is harder than silicon carbide and aluminum oxide. So, and it's also very expensive, and it's also very hard to dress and true, like a diamond wheel. So I think it would depend on what exactly what you're grinding, and Adam says it depends on how lazy he's feeling and which type of wheel is on the spindle. Yeah, so either one of those would grind A2 at Rockwell 60. I think the real question is if you've got some exotic material that is much, much harder, you may have to go with CBN. And Adam says he doesn't generally do flat grinding with CBN. I think it's a pretty specialized material that you've got to mean it. So the answer is I don't know. I've never ground with CBN. I do have a CBN wheel that I play with when I was looking at stone grinding options, and I elected to not go with CBN. So let's answer one question: why use CBN versus diamond? Which is not what you asked, but it's a question I can answer, so I'll choose that. CBN doesn't have carbon in it, whereas diamond is all carbon. And what happens is with a diamond wheel, so M. Najafi says hard-faced with tungsten carbide. Yeah, I could see some hard-faced materials that would want the CBN. So CBN can grind steel without the problem of wheel breakdown that diamond has. So it's almost as hard as diamond, and it doesn't have the downside of breaking down with steel, because diamond is by definition carbon, and that carbon wants to dissolve into the steel. So if you try to grind steel at high speed, which means high temperature, your carbon in your diamonds is going into the steel, and it's going to rip the diamonds out of your wheel, and it's not going to work. But CBN will work. So there you go. Let's see. Fad Radicator says, as a manual user, is the force needed for carbide more aggressive than high-speed steel? Are cutting fluids the same for both? In my experience, you can get high-speed steel sharper than carbide. So you actually can end up with lower cutting forces with high-speed steel. Okay, Adam says nope and nope. Are the cutting fluids same for both? Nope. Nope and nope. So Adam, give us an example. Well, yeah, give us an example. I think it depends on what you mean by carbide. So off-the-shelf carbide is probably not going to be as sharp as as you can make high-speed steel. Hang on, guys. You're getting ahead of me. Put your question in the question box, because I'm going to lose you here, Firmworks. Yeah, I don't know if the difference in force is a practical consideration. Adam says carbide doesn't load the wheel as much as steel. Oh, I misunderstood the question. So if you're talking about grinding high-speed steel versus grinding carbide, then there's your answers from Adam right there. No coolant on the carbide. Carbide doesn't load the wheel as much as steel. Cobalt leaks into the coolant and you die of cancer. Good. All right. I don't know if we answered that one, but I think we beat it to death. Hennessy Matt says, what is the best way to dress an Arkansas stone or a Norton stone with pits and valleys? Well, you could grind it with a diamond wheel on a surface grinder, or you can just purchase a precision flat ground stone from PFG.GG. Yes, that was a commercial. But a diamond wheel is how you can grind your Arkansas stone or your Norton stones. Of course, we don't know anything about grinding Norton stones. Yeah, head over to PFG.GG. Let's see, there was one more question in there. Thank you. So Firmworks says, I've just got a Jones & Shipman 540 sitting on the bottom of the casting with no feet, so I can't level it. Does this matter? So you should level it, and you could use shims to do so. Or you can get leveling feet. If it doesn't have holes or slots for leveling feet, there are leveling feet which are just basically pads. And this grinder sits on 4 points. My Brown and Sharp that I had previously sat on 3 points. And the reasons you should do that are that the grinder was built, it was scraped in, and it was measured while level. So if it's out of level, the stresses on the casting are all going to be different. Is it going to be measurably different? I don't know, but it's different. So leveling it's a good idea. Also from a lubrication point of view and a coolant point of view, if you're going to use coolant, I would level it. So you can get these flat leveling pads that have a bolt on the side, and it's basically a inclined plane. And I would do that. Yeah. So the answer is level it if you can, and if you can't, move on. Good question. Let's see. I think we got everybody's question. I think we did. I'm going to call last call for you're welcome, sir. Last call for questions or comments or snide remarks. And we'll try to get this thing wrapped up at the top of the hour. Oh, another question popped in. Which grinding wheel and grit is suitable for grinding of stainless steel or non-ferrous metal? That's a good question. You could get away with grinding stainless with a white wheel. So, before we said that a good old white wheel is going to be adequate for 99% of your work. That's a good example. You could do it. But for stainless, I have discovered Norton. This is called a 5SG wheel. 5SG. By the way, you can also balance them properly if you get yourself some balancing rings, which I sell on the site. So the 5SG is recommended for stainless, and I did some testing on it, and it was quite nice. But I think Either one of those will work. Now, for non-ferrous materials, sometimes you'll go to silicon carbide wheels, which is also called green wheels. And that's a green wheel. So if you had to do a non-ferrous metal, you could do it with a green wheel. And yes, people grind aluminum. And yes, it's no joke. It sucks, but it's no joke. Okay, tips for adding coolant. Oh, I have a really good tip for adding coolant. I don't think we have time for me to climb on and get it off the shelf here, but the Cool Mist. Cool Mist is the coolant, and Noga makes a mister called Noga Cool, I think. Noga Cool? Am I getting that right, guys? Look at Noga. They make a dual and a single schnozzle coolant attachment. I have a single up here. I used to use it on my Harrod grinder, and it's awesome. So it's basically a mist coolant. Look at the Noga Cool. It's a magnetic base with a spray nozzle, and they're terrific. So that's exactly what I would do. Good question. All right, Fad Radcater. Have an awesome Sunday. I think we did it. Mini Cool. That's it. Is it a Noga? Yeah, that's it. Noga Mini Cool. It's made by Noga, N-O-G-A, and it's called the Mini Cool. Thank you, Warren. I was having a bit of a brain fart. I also have one over on the Bridgeport, and they're fantastic. And the coolant to use is Cool Mist 78. There's a 77 and there's a 78. 78 is the lighter duty coolant, and I would use that for grinding. And that I have used that for grinding, and it works fantastically well. So there you go. We got 3 minutes left. How can we solve the world's problems in 3 minutes? So what are you guys doing today? If you haven't already answered, what's on your plates? So I'll do a quick commercial here for, you already know that I make PFG stones, and that's what I'm doing here today. And this is what we're making today, 6-inch PFG stones. They're on the website at pfg.gg. But also I make balancing wheels, balancing rings, sorry, for specifically for the Sopco B200, Sopco 0200 hubs, which is very common. So all of my wheels get balanced that way, and you could also find that on the website. If you go to pfg.gg, you just go to the main site from there, and it'll go to the purchases area, and it'll show you. But it's or go to kineticprecision.com. All right. Toolmaker is 3D printing or attempting to. Yes. Well, we could talk about that. If you guys ever bring up 3D printing stuff, I've done quite a bit of 3D printing too. That plenum right there, for example, is 3D printed, and we 3D print a lot of tools for the shop, including, of course, the trays for the PFG stones. All right. Well, the sun is still shining. I'm kind of hungry now, so I think what I'm going to do is go eat some lunch, and then I'm going to get to grinding stones because you guys won't let me sleep. So have an awesome Sunday. Stay safe in the shop, and get flat and stay flat. We'll see you guys next Sunday. Oh, thank you for the nice comment there, Toolmaker. It's working, by the way. It's working spectacularly well. So I couldn't be happier. Take care, Warren. Okay, guys, you're awesome. And we're out. We'll see you next week.